It is a great pleasure to have the opportunity sharing the study. There are global concerns of socioeconomic inequality in health, which means the health indicators or diseases distributed unevenly. So to enhance the health of the entire population by reducing uneven distribution of diseases is priority in public health. In Australia, the prevalence of obesity is linked to their area socioeconomic indicators. Overall, those living in deprived areas are more likely to suffer weight problems. In this figure, the three areas highlighted in red indicates the highest prevalence of obesity, 61% to 55%, which are far above the national average of 31%. The three areas shared some common characteristics. All of them showed below average level of educated population and household income, as well as above average level of unemployment. By contrast, a couple of areas are less likely to have obesity. The areas are generally characterized by higher socioeconomic status. The four areas highlighted in blue in the figure show the lowest prevalence of obesity in Australia. Their obesity prevalence are around 14 to 15%, apparently much lower than the national average. All the four areas showed above average education and income levels, as well as below average unemployment rates. So it is important to understand the potential mechanisms through the behaviors of the socioeconomic inequalities in health. Established studies has examined the roles of some specific health-related behaviors of the relationship, but they mainly investigated other behaviors such as smoking, alcohol consumption, and dietary intake. Some of them focusing on the physical inactivity, but mixed findings have been reported, as using overall measure, in which behaviors across different domains are combined, may obscure the true socioeconomic variations in these behaviors and their roles in increasing disease risk. So the aim of the study was to examine the potential mediating roles of physical activity and sedentary behavior by domain and the socioeconomic status and cardiometabolic risk relationship. We used Australian national sample from the third wave of the OSTIAP, which was conducted in 2011 and 12. This study consisted of three waves. The first wave, OSTIAP 1, was conducted in 1999 to 2000. It was originally aimed to examine the prevalence, incidence of diabetes and its risk factors in the national sample. The participants were recruited using a two-stage stratified cluster sampling approach. So they will first select 42 study sites, then invite the adults aged 25 years or above at baseline. There were around 4,600 of participants included in OSTIAP 3. We extract neighborhood socioeconomic and status information from the census, and the composite index consisted of indicators such as income and education. So a lower score indicates a more deprived neighborhood. For the cluster score of cardiometabolic risk, it was based on 5 biomarkers. A positive, higher score indicates a greater cardiometabolic risk. We also identify potential mediators for different domains of physical activity and sedentary behaviors, so including walking for transport, recreational physical activity, moderate and vigorous intensity separately, household physical activity, transport-related sitting time, and television viewing, computer use for recreation sitting, as well as occupational sitting time. So to consider the cluster area clusters of these participants, we use the two-level multi-level mixed effects linear regression models to take that into account. All the models were adjusted for a range of potential confounders listed. So here is the framework for mediation effect. The first step is to examine the total effect, namely examine the association between neighborhood socioeconomic status and cardiometabolic risk score. Then to test whether the total effect is explained by specific physical activity or sedentary behavior. So we identified the associations between the socioeconomic status and each behavior, as well as the associations between behaviors and the cardiometabolic risk score. So if the regression coefficients alpha and beta are both statistically significant, it is suggested a mediation effect based on the joint significance test. So here is the finding. We found the total effect was significant. Higher neighborhood socioeconomic status was associated with lower cardiometabolic risk score. And this relationship was explained largely by more time in vigorous intensity recreational physical activity, around 15%, followed by less time in television viewing and more frequent walking for transport in higher socioeconomic status suburbs than their lower counterparts. However, we also found transport-related sitting was identified as a mediator, suppressing the socioeconomic inequalities in cardiometabolic risk. So our findings suggested that public health initiatives encouraging active lifestyles, for example, active travel and a leisure domain for such as the sports and exercise, as well as reducing long periods of television viewing, have the potential to close the health gap. And such initiatives will need to be implemented for those disadvantaged neighborhoods especially. So future research is required to corroborate the finding, as well as clarify the roles of transport-related sitting in such health inequalities. I would like to acknowledge colleagues who helped me with the study, and thank you very much.